water topic for this morning, but it is already also in line laman gihapon sa topic natin a while ago. So that would be pipe connecting reservoir. Okay, so ano ba yung reservoir? It is the large storage of water like your Angat Dam, no? That is considered as a reservoir. No, kung napanood niyo yung past videos natin about the lectures. So meron pa rin tayong head losses na i-consider dito, no? Kasi meron tayong connection ng pipeline system natin sa mga reservoir. Okay, so we have still to consider the three main formulas for your head losses. That will be the Darcy-Weisbach, the Mannings, and the Hazen-Williams. Okay, so you have here a formula. Sabi niya dito Q1. So you have two cases. No, you have two cases. You have your case 1 and you have your case 2. So itong pipe connect, medyo maingay ba ang audio natin guys or sakto lang? Okay lang?
Sakto lang.
Okay, okay, sige. So you have here pipe connecting reservoir. So this type of topic no is usually present siya sa mga board exam topics natin. Okay, so all those three reservoirs na nakikita nyo, one, reservoir A, reservoir B, and reservoir C, no, they are connected into a single point. So, ibig sabihin, itong pipeline system natin is nagmi-meet sila sa isang point lang, which is, hindi magsulat, wait lang, which is this point, no? This point, this single point. Lahat ng pipeline natin from reservoir A, reservoir B, and reservoir C is nagmi-meet sila sa isang single point, which is called as your junction. Okay? Pag-aalala, this term is called as your junction. So even if you have consideration na single point, pwede kayong magkaroon ng datum ninyo on your own. Like for example, sa case 1 natin, ang datum niya, no, dito niya kinonsider yung datum niya para mapagbasihan niya ng head losses natin. Okay, so itong datum niya, dito niya kinonsider from your reservoir A papunta sa datum, that would be considered as your head loss number 1. From the datum natin papunta sa reservoir letter B natin, that would be considered as your head loss number 2. So from the datum papunta sa ating reservoir C, so that is considered as your head loss number 3. So the same as well sa case 2 natin, ang kanyang datum is nandito. No, it's up to you kung saan ka magde-datum, no, kung saan mo pagkukunan yung datum niyo. So case 2 natin is nandito, sa lahat ng head losses natin is papunta kung nasaan yung datum na kinonsider mo as your reference. Okay, so you have here your H daw. Sabi niya dito, your H1 is considered as your H1 plus H2. So itong H na ito, it is the total head loss. It is the total head loss between the two reservoir. Okay, it is the total head loss of your reservoir A and reservoir B. Nakikita naman natin, yung H1 ninyo, that would be consist of head loss number 1 at head loss number 2. Okay? Ano pa ba? So you have here your H1 can be considered also as your elevation A minus elevation B. So ibig sabihin, pwede din daw natin makuha yung total head loss between two reservoir by the difference between the two elevations. So kung for example, ang ating reservoir A, meron siyang elevation na 10. Okay? Tapos yung reservoir natin, mas mababa siya. Meron tayong elevation na 5. So paano doon natin makuha yung total head losses between your reservoir and A? Ima-minus lang natin siya. Therefore, your head loss 1 is considered as 10 minus 5. Therefore, that would be 5 meters. Yun yung sabi niya eh. No, your head loss 1 is considered as the difference between your elevation at A at elevation at B. Yung head loss at 2 natin, your total head loss between B and C, that would be considered, kanya sabihin natin ang elevation sa C, that would be 3. Therefore, your head loss at 2, your total head loss 2, that will be 5 minus 3. That will be equals to 2 meters. Okay, yan yung magiging consideration natin. The same as well sa case 2 natin. Yan yung mangyayari. Sige, para mas intindihan natin, let us have an example of that. So you have here, sana nakikita nyo yung figure, no? Sana maklaro nyo. Paki-zoom na lang kung hindi. So in the pipeline system shown below, we will use the Mannings, which is the roughness coefficient, which is 0.11. So let us try to compute the discharge flowing towards C, and we will determine the rate of flow. So for example, ganito, hindi natin alam kung saan yung tubig, kung saan yung flow ng tubig, kung galing ba point E, dinidistribute niya sa B and C, or sa C ba, dinidistribute niya from B and A. So, aalamin natin yan. Okay? So, paano ba natin makuha ang discharges natin? Okay? So, pwede tayo gumamit ng Q is equals to AV. Pwede yan kasi discharge yan siya eh. But then again, wala tayong velocity. Therefore, X na agad itong formula na ito. Saan pa natin pwede makita ang ating Q? Sa ating head loss. Okay? So, since N yung binigay, Manning's formula tayo for head loss, can we confirm the formula? I think that would be 10.29 N squared LQ squared divided by D 16 over 3. Tama ba yung formula natin? Tama, di ba?
Yes, ma'am.
Okay. Okay. So that will be the head loss for your Manning's formula. So discharge yung hinahanap natin, gagamitan natin ng head losses. So ano yung problema natin? Hindi natin alam yung head loss between the reservoirs. Okay? So you have here, ang datum niya is level lang ng ating reservoir B. You know, based on the problem, yun yung nagiging datum niya. So therefore, you have here your head loss at 1 and you have your head loss at 2. So based sa principle kanina, pwede daw natin makuha yung head losses, 'di ba? Pwede natin makuha yung head losses between the difference between the two elevations. Ibig sabihin, pwede natin makuha yung HF1 or yung head loss at 1 natin with the difference between the elevation at A minus the elevation at B. Ganyan na lang, Z na lang yung magiging variable ko ha. So therefore, you will have your head loss at 1, that would be 30 minus 24. So, ibig sabihin, your head loss at 1, that would be considered as 6 meters. Tama? So, how about head loss 3? Francis, paano ba yung head loss at 3 natin? Can you try to solve? Prahinog. Nakamute.
Ma'am?
So, what would be the head loss at 3 natin? Kaya, kunin na lang natin lahat ng head losses. Ano yung head loss at 3 natin?
24. Wait lang, mama. 24 minus 15. Manigurado to, mama. 9.
Mga yun. Sige, that would be 9 meters. Sabi niya, 9 meters. Saan ba nanggaling yung 9 meters na head loss na yon? That would be the elevation coming from B minus the elevation coming from C. So that is 24. That is 24 minus 15. Sana naintindihan paano natin nakuha yung head losses natin. So in this case, pwede na natin makuha yung discharge natin at C. Tama? Kasi meron na tayong head loss at 0.3. Okay? So you have here, HF3 is equals to, hindi ko na lang isulat ulit yung equation. No? Sige na lang, sulat na lang natin. Marami na pa naman tayong space. So that would be 10.29. Yung N natin, that would be 0.011 squared. Ilan yung magiging L natin? That would be 1,500. QC squared divided by your diameter, which is 0.15 based sa problem natin. That would be 16 over 3. Palitan natin yung head loss. Palitan natin yung head loss. Yung head loss daw natin is equals to 9 meters. Pwede man dito mag-change color, no? Sige. So, ilan yung magiging discharge at C natin? Zero point
0.014.
0.014. I think that is correct. 0.014 cubic meters per second. So can you say thumbs up if you got the same answer? Okay, Repol, I can see thumbs up. How about sa iba? Okay, Salmon. Sino pang? Okay, Hervia.
Same, ma'am.
Okay, sige. Thank you, Mali. Okay, I can see all of your thumbs up. So thank you. So tama na, no? Nakuha na natin yung what is being asked, no? Sa flow of water reservoir C, check. So ano na lang yung kailangan nating alamin? Let us try to determine the flow of water. So let us try to get the discharge at letter A. Kasi di ba kung titignan nyo, mas mataas yung elevation at A. So kung kayo pa lang, i-assume nyo talaga na yung tubig is magpo-flow from A papunta sa B at C. Parang yung magiging equation natin magiging ganito. QA is equals to QB plus QC. Okay? O, sige, pilit tayo kay hina internet. Parang ganyan. So let us try to determine kung sino yung mas mataas na discharge. Ibig sabihin ko, sino yung mas malaking discharge na makukuha natin? Doon nangyayari or doon nang gagaling yung flow ng tubig natin. So it is the battle, battle talaga. It is a battle between your reservoir A and your reservoir C. Okay? So let us try to solve for the discharge at letter A. So since you have your head loss HF1 as 6 meters, pwede nyo nang makuha ang discharge at A. So sulat ko na lang ulit habang nagsasolve kayo. Alam nyo naman yung gagawin. Hinahinaan ko lang sulat kasi medyo mahina yung internet. Ang L natin, that would be 1,200. So you have QA squared. And the diameter is 0.3. That is 6 meters yung magiging head loss natin.
Ma'am, ang ano good ma'am, ang power sa 0.3 kay 16/3, di ba?
Ay, oo. Sorry. Nasanay sa Darcy Weisbach. 16/3. So you will get the value of your QA. Hindi pala natin lagyan ng line.
0.081, ma'am.
0.081. I guess that is correct. That would be 0.0881. Okay. Okay,
Opo,
Kulama,
ma'am.
I can see your thumbs up. Okay, thank you. I can see your thumbs up. Thank you for the answer. So that would be 0.081 cubic meters per second. Sige, line na lang natin. So therefore, we can conclude that your QA is greater than your Q3. Okay, therefore we can conclude that the rate of flow or the direction of the water is coming from your pipeline or your reservoir A. So ibig sabihin yung flow ng tubig natin, no, nadadagdagan yung reservoir B ninyo at reservoir C ninyo from the water coming from your reservoir A. Okay, so that would be the conclusion. Okay, so naintindihan anong nangyari? Okay tayo? Can I say thumbs up if okay tayo sa nangyari sa ating problem? Okay. Okay, thank you. So we are down to our last example for this morning. So you have here, medyo maraming values tayong nakikita. So sabi niya, you have 3 reservoirs A, B, and C that is being connected to your pipeline 1, 2, and 3, which is meron kayong junction having a X value. Okay, so meron kayong junction na kino-consider. And you have here, elevation, yung elevation A niya is 300, elevation B is 285, and elevation C is unknown. Okay? The rate of flow from the reservoir is considered as 1.4 cubic meters per second. So hahanapin natin yung discharge at C, discharge at B, discharge at C, at yung elevation at C natin. Okay, so having this one, no, let us try to solve for the total head losses, no, para makuha natin yung discharge at B natin. Kasi we all know yung discharge at B ninyo, that is considered as your QB. So ano ba yung coefficient na binigay? Hindi ko nakikita. So F yung binigay, so therefore that would be Darcy Weisbach formula. So pwede nyo makuha yung QB ninyo if you know your HFB. Tama, or your HF2. So based on the figure, nakikita nyo that your HF2 is 3.36. So mamaya aalamin natin paano kaya kinuha yung 3.36 na yan. So let us try to have the, since given naman siya the answer problem, no? So let us try to have this equation. So you have HF is equals to 0.0826 FL Q squared D raised to 5. Since your HF2 given is 3.36, kindly try solve the value of your QB. Hindi ko na lang isulat kasi limited lang yung ating space. So, given naman lahat, no? For your B, that would be diameter is 600, length is 450, and the friction factor. Mamaya, ipapakita ko saan nanggaling itong 11.64, saan nanggaling itong 3.36. Kunin muna natin yung discharge at point B. Is it? Zero point
0.39.
39?
0.66, ma'am.
66. Is that 0.659?
659, ma'am.
Okay. Katawa ko yung magna.
9, ma'am.
Okay, that would be 0.659. Okay na siya, magna. That would be 0.659 cubic meters per second. Can you see a thumbs up if you agree sa value ng discharge B natin? Agree? Agree? Agree ba? Agree? Okay, mahaling? Baliad? Balyad? Okay, I can see your thumbs up. Okay, Konkon, Repol. Okay, can see your thumbs up. Therefore, we have your answer for your letter A. So, bago tayo mag-proceed sa letter B and letter C, I want you to know kung paano dito sa figure, paano kung sa figure hindi pinakita itong 11.64 at paano kinuha itong 3.36. So, according natin kanina, di ba, we can get the difference or the total head loss between the two reservoirs, between the difference between the two. So, if ito yung maging H1 natin, H1, di ba that would be the difference between the elevation of your reservoir A and that would be the difference between your reservoir B. So that would be 300 minus 285. Ilan yan? Panigurado, same kay Francis. Ilan na siya?
15, ma'am.
That would be 15 meters. Pakitry nga add 11.64 plus 3.36 kung 15 yan siya. 15?
Yes, ma'am. 15.
Yes,
15,
ibig sabihin 15. So alamin natin bakit siya na-dissect into 11.64 and 3.36. So take note, according to the problem, that you have a discharge for your point A, which is 1.4 cubic meters per second. Okay? So kung meron kayong discharge, meron kayong diameter, meron kayong length, meron kayong friction factor, pwede nyo nang makuha yung head loss at 1 ninyo. Sige nga, paki-confirm. Kunyari, hindi nyo alam itong value na ito. Pakikuha nga ng head loss at 1 natin, having a discharge of 1.4 cubic meters per second. Tingnan natin kung 11.64 ba talaga. Basta ginascam lang dahil ito sa figure. Considering your A values. So yung length natin, 1,500. Ang diameter natin, that would be 800 mm. And your F, that would be 0.0157.
11.635, ma'am.
11.635. So, kinonvert, ay niround up niya lang to decimals. So, agree na ba tayo? Hindi na masakit yung loob natin saan nanggaling yung 11.64? Agree? Nakita na saan nanggaling? So, alamin natin saan naman kaya nanggaling yung 3.36. Madali lang yan. So, you have your H1 is equals to your HF2. HF1 pala muna. HF1 plus your HF2. And you all know that your H1, that would be equal to 15. Tapos yung HF1 ninyo, that would be 11.64 plus your H2. Tama ba na ang H2 ninyo is 3.36? Agree? Agree? So nakita niyo na
Yes.
saan nanggaling yung 11.64 at saan nanggaling yung 3.36. No, I hope that makes sense, no? Na gets natin siya. So let us try to solve for the rate of flow of your reservoir C. So in this manner, no, kung pag-iisipin natin, ang flow of water natin is nanggagaling sa ating reservoir A. So the same sa pipe, series pipe parallel natin, pwede tayong gumawa ng equation that your QA is equals to the discharge at point B plus the discharge at point C. And you all know that the discharge at point A, that would be 1.4. And discharge natin sa B, that would be 0.659. Therefore, we can get the value of your discharge at C. Ibig sabihin, yung flow natin ng tubig or yung distribution of water is nanggagaling sa ating reservoir A. So, ilan yung magiging Q, C natin? That would be 1.4 minus 0.659. Is it 0.17?
0.741.
0.741, ma'am.
That would be 0.741 cubic meters per second. So letter B is check. Okay, isang problema na lang yung isosolve natin para makalunch na tayo, no? Isang problema na lang talaga. So for letter C, tinatanong natin dito, let us compute for the elevation of reservoir C. Yung elevation na naman daw. Di ba kanina, nakukuha natin yung ano ba yan? Nakukuha natin yung head losses natin between the difference between two reservoir. Diba? Yan kanina, nakuha natin yung head loss. So ngayon naman, ang binigay naman sa atin ng figure is yung total head loss ng 0.3 natin. That would be coming from your reservoir C papunta sa datum natin, which is hanggang dito. No, yung datum natin. So that would be equivalent to 52.20. Huwag na tayo makipag-away saan ang galing yung 52.20. Given na yan siya. No, given na yan siya sa ating figure since wala tayong reference ng elevation at C since it is unknown. So ano yung gagawin natin? So let us have elevation at C. Wait lang. Elevation at C natin. So you have here elevation at C. So di ba yung elevation at C natin, that would be the difference between these two. Ay, elevation natin, asan tayo? Wait lang. Ito yung magiging elevation natin. Consideration of our elevation C or ZC na lang yung ilalagay ko. So having that said, we have our total head loss as 52.20. So ano yung gagawin natin? Pakita ko muna kung ano yung magiging equation. That would be, galing sa datum natin, that would be the head loss of 2. Okay? Plus the elevation ZB na lang pala para mas madali. That would be the elevation coming from your reservoir B minus your head loss at 0.3. Okay? Paano nangyari yon? Di ba yung total head loss natin is galing sa datum papunta sa reservoir natin na C. So para makuha natin itong value na ito, we need to minus or i-add natin no, yung value na ito, i-minus natin sa total head loss natin sa 0.3 para makuha natin tong portion na ito. Nakikita ba? Nakikita ninyo? No? So, ibig sabihin, i-add natin yung head loss. Iba kasi yung head loss, iba din yung elevation, kaya ina-add natin siya. Okay? Yung head loss at 2 at yung elevation at B, i-minus natin sa total head loss at 3 para makuha natin itong portion na ito. Sana nakikita nyo, no? Para maintindihan natin. So, you will have 3.36 plus 285, pilit na punta guys, minus 52.20. Therefore, you can get the elevation. Okay. Pilit na siya.
236.
Wait sa. Elevation C. Ilan yun, Con?
236.16.
236.16
16.
meters. So can I say thumbs up if you got the same answer as Concon? Okay, Magna, Ortiz, Barcelona. Okay, sana yung mga nag-off cam today, no, next meeting, sana makita ko rin kayo. Char, sana makita ko rin kayo na naka-on cam kayo. Okay, Fabro, I can see your thumbs up. Coloma. Okay, so I guess this ends our discussion for this morning, no? Lunchtime na tayo. So do you have any concern or clarification about today's topic? Or nuggets pa? Okay pa tayo sa pacing? Okay pa? Kaya pa?
Ma'am, pwede ba siya nga ibang ma'am, ibang way pero same answer?
Yes, you can solve that one anyway lang, yapon. Basta the principle is there sa pag-solve mo. Okay lang.
Sige,
There's so
ma'am.
many ways to kill a cat man, di ba? It's okay. Basta ang principle is always there. Okay na?
Ma'am, i-upload ba nini mo sa Schoology, ma'am?
Ang material, i-upload ko